Assalamualaikum and hello everyone. In this video, I'm going to show you the solution for example in tutorial note for chapter 7. Question 1, which is about angular displacement or the symbol theta. Okay, in this question, there are two communication satellites are put into an orbit whose radius is r equal to 4.23 times 10 to the power of 7 meter. Okay, so the radius from the satellite to the center of the earth is given. Okay, the two adjacent satellites have an angular separation of theta equal to 2 degree. Okay, so these two satellites are separated by 2 degree angle. Okay, so the question wants us to find the arc length, which is the s. Okay, so as we all know, if you want to find the s, we are going to use formula s equal to r theta. Okay, so the value of r is given here, and as you can see, it uses SI unit, which is good. Okay, but the theta are not in SI unit. The theta is not in SI unit, so we need to change the unit first. Okay, so we are going to change it. Theta equal to 2 degree over 360 degree times with 2 pi. Okay, the answer is 0.0349 radian. Okay, so after we change the unit, so we can substitute the value of r and the value of theta into the formula. So we're going to get s equal to 4.23 times 10 to the power of 7 times with 0.0349. Okay, so the answer is 1.48 times 10 to the power of 6 meter. So this is the answer. Question 2, which is about average angular velocity. The symbol is omega. Okay, a gymnast on a high bar swings through 2 revolutions in a time of 1.9 seconds. So in this one sentence, you have been given 2 information, which is 2 revolution and the time. Okay, so the question wants us to find the average angular velocity in unit radian in SI unit of the gymnast. Okay, so the formula for average angular velocity is omega equal to theta final minus theta initial over time final minus time initial. Okay, so you have been given here 2 revolution, which is the value for theta, and 1.9 second, which is the value for time. Okay, so but as you can see, revolution is not in SI unit. Okay, so that means we need to change it into SI unit first. Okay, so 2 rev is equal to 2 times 2 pi, which is 4 pi rad. Okay, so and then we can just substitute the value of theta, this theta, and time, the value of time. Okay, so we're going to get omega is equal to 4 pi over 1.9. Okay, so the answer will be 6.63 radian per second. Next is question number 3, which is about average angular acceleration, or the symbol is alpha. Okay, in this question, the fan blades are rotating with an angular velocity of 110 radian per second. As the plane takes off, the angular velocity of the blade reaches 330 degree radians per second in a time of 14 seconds. Okay, so the question wants us to find the average angular acceleration. So the information given is omega initial, which is 110 radian per second, and then we have been given omega final, which is 330 radian per second, and then you also have been given the time, okay, the time, which is 14 seconds. Okay, so if we want to find the average angular acceleration, so the formula will be alpha equal to omega final minus omega initial over delta t. Okay, so substitute the information into this formula. We will get 330 degree minus 110 divided by 14. Okay, and the answer will be 15.71 radian per second squared. So this is the answer. Okay, next question number 4, which is about relations between angular and linear quantities. Okay, so in this question, a helicopter blade has an angular speed of 6.5 rev per second. So you have been given omega. Okay, and has an angular acceleration of 1.3 rev per second squared. Okay, you have been given the value of alpha. Okay, so for point 1 and 2 on the blade, find the magnitude of the linear velocity and the tangential acceleration. Okay, so the question wants us to find the linear velocity and tangential acceleration for point 1 and point 2. Okay, so let's look at the picture here. Okay, so the point 1 is here, okay, which is 3 meters from the pivot of the fan blade. Okay, whereas point number 2 is here. Point number 2 is here, which is 6.7 meter from the pivot. Okay, all right. So as you can see, the information given for both omega and alpha are not in SI unit. Okay, so which means that we have to convert these two information into SI unit first. Okay, so let's do that. So for omega, so omega is equal to 6.5. Okay, so which is equal to 6.5 times 2 pi over 1. Okay, so we're going to get value of omega in SI unit is 40.8 radian per second. Okay, so for alpha, which is 1.3 rev, 1.30 rev per second squared. So if we want to change into SI unit, so it's going to be 1.3 times 2 pi, okay, over 1. Okay, so we don't need to change the time, the unit for time, because the unit for time is already in SI unit. Okay, so the value of alpha will be in SI unit will be 8.17 radian per second squared. Okay, after we change all the information given into SI unit, okay, we can substitute those information into the formula. Okay, for question A, okay, the question wants us to find the linear velocity. Okay, so the formula for linear velocity is V equal to R omega. Okay, so this is for point 1, which is we can also write R, which is R to be R1. Okay, same goes for point 2, V equal to R to omega. Okay, so from the previous slide, okay, so the value of R1 is 3 meter. Okay, 3 times the value of omega is 40.8. Okay, so put this formula into your calculator, and you will get the answer is 122 meter per second. Okay, for point 2, okay, for point 2, the radius is 6.7. Okay, 6.7 meter, while and the omega that we calculated from the previous slide is 40.8. Okay, so put these values into your calculator, and you will get the answer is 27.33 meter per second. Okay, so this is A. Okay, for B, the question wants us to find the tangential acceleration. Okay, so the formula for tangential acceleration is A, or we can also write AT equal to R alpha. Okay, so this one is R1. Okay, same goes for point 2. AT equal to R2 alpha. Okay, so substitute the value of R and value of alpha. So the value of R is 3, alpha which we have already calculated in previous slide is 8.17. Okay, so put in your calculator, and you will get the answer is 24.5 ms negative 2. ms negative 2. Okay, so for point 2, the value of R is 6.7. Okay, the value of omega alpha is 8.17. Okay, so put it in your calculator. The answer will be 54.73 meter per second squared. Okay, so these are the answers. Okay, next, question number 5. Okay, discus thrower often warm up by throwing the discus with a twisting motion of their bodies. Okay, starting from rest, the thrower accelerates the discus 55.6 radian per second. Okay, so you have been given the value of alpha, which is angular acceleration. How we know that? Because the unit radian here. Okay, to a final angular velocity of 15.0 radian per second before releasing it. So you also been given the value of omega. Okay, so during the acceleration, the discus moves on a circular arc of radius 0.81 meter. Okay, so this value radius here is also the length of this person hand. Okay, so the question is, find the magnitude A of the total acceleration, okay, of the discus just before the discus is released. Okay, so the question wants us to find the total acceleration. Okay, so as we know, the total acceleration, the formula for total acceleration is A equal to tangential acceleration squared plus centripetal acceleration squared. Okay, so first we are going to find the value for tangential acceleration. Okay, as we know, the formula for tangential acceleration is AT equal to R alpha. Okay, AT equal to R alpha. Okay, so substitute the information given. R is 0.81. Alpha is 55.6. Okay, so calculate the value. We will get 45.0 ms negative 2. Okay, so next we are going to find the linear acceleration. As we all know, the formula for linear acceleration is AC equal to R omega squared. Okay, AC equal to R omega squared. So the value for R is 0.81. The value for alpha omega is 15. Okay, 15 to the power of 2. Okay, so calculate the value. We will get 882 meter per second squared, ms negative 2. Okay, so after we calculate both tangential acceleration and centripetal acceleration, we can substitute into the total into the formula, and we will get the total acceleration will be, okay, so third 45 squared plus 182 squared, and the answer will be 187 ms negative 2. So this is the answer. Okay, next question number 6, which is about rotational motion with constant angular acceleration. Okay, so the question, an automobile starting from rest, okay, which is the velocity will be 0, has a linear acceleration to the right whose magnitude is 0.8 ms negative 2. So here we have been given the value of A. Okay, so here also we have been given the value of omega naught. Okay, so during the next 20 seconds, okay, the value here you have been given the value of time. The tire roll and do not slip. The radius of each wheel is 0.33 meter. Okay, so this is the value of R. Okay, at the end of this time, what is the angle through which each wheel has rotated? Okay, so the question wants us to find the value of theta. Okay, the question wants us to find the value of theta. Okay, so what formula should we use? Okay, so based on the information given, okay, we can deduce that the formula that shall be used is theta equal to omega naught t plus half alpha t squared. Okay, so we have the value of omega, we have the value of time, but we don't have the value of alpha, but we can find the value of alpha. Okay, so how? So we are going to use the relationship between linear acceleration and angular acceleration, which is A equal to R alpha. Okay, so substitute the value into this formula. A is 0.8 and R is 0.33. Okay, so find the value from your calculator. Calculate the value. So we will get alpha is equal to 2.42 radian s negative 2. So this is the value of alpha. So now we have all the information needed. Okay, so substitute all the information into this formula. Okay, so omega naught is what is the value of omega naught? So since the automobile start from rest, so the value of omega naught is 0. T is 20. Okay, so plus half alpha is 2.42. Okay, and t squared 20 squared. Okay, so 0 times any number is going to be 0. Okay, so calculate the value and you will get the value of theta is equal to 484 radian. So this is the answer. Okay, next question number 7. Okay, so in this question, A car is moving in an anti-clockwise direction on a circular road whose radius is r equal to 390 meters. Okay, so this is the road. Okay, and the radius is given. Okay, so the speedometer reads a steady 32.0 ms negative 1. Okay, so question number 1, what is the angular speed of the car? Okay, and then question B, determine the centripetal acceleration of the car. Okay, so you have been given here the value of r, and you have been given here the value of v. Okay, so the question wants us to find the angular speed. So angular speed, which is the symbol is omega. So as you all know, if we have the value of v and r, we can find the value of omega. So what is the formula? The formula is v equal to r omega. So check the unit. So all units are in SI unit already. Okay, so just substitute the value. So 32 equal to 390 omega. Okay, so find the value of omega, and we will get 0.0821 radian as negative 1. So this is question A, angular velocity or angular velocity. Okay, all right. So next, question B. The question wants us to find the centripetal acceleration. So as we all know, the formula for centripetal acceleration is C equal to r omega squared. Okay, so we already have the value of omega. So just substitute the value of omega and substitute the value of r. Okay, so the r is 390. Okay, while the value of omega is 0.0821. Okay, squared. So find the value using your calculator, and you will get the answer is 2.63 ms negative 2. Okay, so this is the answer. Okay, next, question C. The car suddenly applied the brakes and reduced its angular speed to 4.9 times 10 to the power of negative 2 radian per second in a time of 4 seconds. So the question is, what is the tangential acceleration of the car? Okay, so as we know, the formula for tangential acceleration is a t equal to r alpha. So if you want to find the tangential acceleration, you need to find first the value of alpha. So how can we can do that? So let's find a let's refer to the information given. So here you have been given the value of omega naught, and here is the final angular velocity, which is omega f. Okay, so and here is the value of time. Okay, so we can use the formula omega equal to omega naught plus alpha t. Okay, so you can rearrange this formula into alpha. Alpha is equal to this omega here means omega final. Okay, so omega final minus omega naught over time. Okay, so just substitute this information into the formula that you have derived. Okay, so the value of alpha will be 0.0821 minus 4.9 times 10 to the power of negative 2 divided by 4. Okay, so you will get the value of alpha is negative 8.28 radian as negative 2. So this is the value of alpha. So we have obtained the value of alpha. So we can substitute the value of alpha into this formula to find the tangential acceleration. Okay, so times the value of radius, which is 390. Okay, times with the value of alpha, 8.28. Okay, so you will get the value of tangential acceleration is equal to negative 3.22 ms negative 2. So this is the answer. Alright, last question. Question number 8. A gymnast is performing a floor routine. In a tumbling run, she spins through the air, increasing her angular velocity from 6 pi to 10 pi radian per second, while rotating through 1/2 of a revolution. Okay, so question A, determine the angular acceleration, and question B, how much time does this maneuver take? Okay, so let's look at the information given. Okay, first, you have been given the value of omega naught. Okay, and this one is the value of omega final. Okay, so rotating through 1/2 of a revolution. So you have been given the value of theta. Okay, so the question wants us to find the angular acceleration. So from the information given, we can use the formula of omega squared, omega final squared, equal to omega naught squared plus 2 alpha theta. Okay, so this is the formula that you shall use. Okay, so just substitute the information given, but before that, you should notice that the value of theta is not in SI unit. Okay, so first, before you substitute the value of theta, you need to change the unit of theta into SI unit first. So how should we do it? Okay, so theta is equal to 1.5 ref. So equal to 3/2 times with 2 pi. So you will get 3 pi radian. So this is the value of theta. Okay, so now you can substitute all the information into this formula, and you can find the value of alpha. So the value of omega final is 10 pi squared equal to 6 pi squared, okay, plus 2 alpha. Your theta is 3 pi. Okay, so you can first you need to transfer this, and then you can find the value of alpha, and the value of alpha will be 33.5 radian per second, radian s negative 2. Okay, so this is the value of angular acceleration. Okay, now for B, how much time does this maneuver take? Okay, so what formula shall we use? Should we use? Okay, for this question, we can use the simple formula, which is omega equal to omega final equal to omega naught plus alpha t. Okay, so substitute the formula, substitute the information that you have been given. So omega final is 10 pi. Okay, omega naught is 6 pi plus alpha you have calculated here is 33.5, and you want to find the value of t. Okay, so use your mathematics skill. Okay, and then you will get the value, the answer for time time taken is 0.375 seconds. So this is the answer for your question. Thank you.